Hey guys, Mrs. Sperber here. I just wanted to go through 7.4 with you. This is applying properties of similar triangles. So in 7.3 we talked about triangles that were the same shape, just bigger or smaller, and we could use side angle side similarity or side 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 similarity or angle angle similarity. So these are saying when you have similar triangles, just some other ratios that we know to be true. So we're going to do 3 different theorems today and 3 different examples. So 1 example per theorem. So 7.4, applying properties of similar triangles. The first property says that if you have a triangle within another one, so here's this big one, and then this green one, this green one is inside of it. These obviously have the same angle right there. And it's saying if line RS, so if that is parallel to that, basically then we know these angles are the same because of corresponding, so we've got angle-angle similarity. So they're saying if you have one within another like that and they're parallel, you can say that XR over RQ is equal to YS over SQ, aka if this is 2, and that is 8. If this one is 3, 2 over 8 is 1/4, so 3 over what would be 1/4? So 3 over 12. So you're just saying that ratio, 8 to 2, 12 to 3 is the same. So here's our example problem. We know that they're parallel, so we've got the green one, and then the bigger one, which is pink. And then they did say that they're parallel. That's these little arrows right here. And so we can say for the green one that the 9 over 4x minus 2 is the same as the 12 over the 3x plus 2. If you'll notice, the whole line of the pink triangle is 12 plus 3x plus 2. You can do that, but here it just says you just need the top divided by the bottom or the bottom divided by the top. So you don't have to do the whole entire pink length, just the bottom part and then the green length. So again, just 12 over 3x plus 2, not 12 over 12 plus 3x plus 2. That gets kind of tricky. There's different scenarios when you do different ones. But for this theorem, it's just this part over this part. And that equals this part over this part. So then all we have to do is cross multiply and solve. So we get 12 times 4x minus 2 equals 9 times 3x plus 2. Distribute, that's 48x minus 24. I'm doing this in my head, so see if I make any errors. 27x plus 18. Add 24 to both sides. Do a little bit of algebra. 18 plus 24, 42. Divided by minus 27x. That gives me, oh gosh, my brain is hurting with all this mental math. 21x equals 42. Divided both sides by 21. And x is 2. And they just asked for x. They didn't ask us to plug it back in. You could plug it back in to just kind of check that the triangles are similar, but this should be your answer. So that is the first theorem. They call it triangle proportionality theorem. I read on the internet some people call it crossbar and some people call it side splitter. The technical name is triangle proportionality theorem though, but people recognize these as well. Okay, the second one is called transversal proportionality. It's super similar to the first one. It's saying if you had that pink triangle, but it's saying what if you just, and you still have the green one, and they said this is still parallel to this. The only difference here is they take another parallel line and then they cut off the tops of the triangle. So it's just like the other one. It just has the top of the triangle kind of cut off. So what they're saying there is this ratio, let's say if this was 2 and this was 6, if this was 3, this would have to be 9. So same kind of ratio, the top over the bottom equals the top over the bottom, or vice versa, 6 over 2 equals 9 over 3. It's just the top of the triangle is kind of cut off this time. So transversal proportionality. I'll circle this for you guys. Okay, so here's our example. They were a little sneaky. They turned the triangle sideways. That's a rectangle. Okay, and it looks like it's very, very long. It's going to practically go off of the page. So I'll draw it piece by piece. Not even enough room on the iPad. But it will make a point to the triangle somewhere there off the edge of the paper. Then we've got our green one. Again, it's going to meet up on the edge. Makes sense why they cut it off. It was too big. So then they told us this line is parallel to this one, and then they cut the top of the triangle off with a parallel line. So cut it off here. And so we can say that the 62 over x, again, this triangle is just sideways, that is equal to the 56 with the green over the 70. And then just cross multiply and solve. These I don't think I can do in my head. I'm going to have to use my calculator. So 56x equals 70 times 62. That's 4340. Divide both sides by 56. And I got 77.5 feet. Make it pretty. And they just asked for the length x, so they didn't ask us to plug it back in. We could, of course, plug it back in and just kind of double check that our numbers check out. So that is 2 transversal proportionality. So just reviewing, we've done triangle proportionality theorem. We've done 2 transversal proportionality, which is kind of the same, it's just with the top of the triangle cut off. And then our last one is called triangle angle bisector theorem. So what it's saying, I'll use different colors. If you have a triangle, there we go, and so that's the triangle portion, and then you look at one of the angles, so I'm going to look at angle A, and you bisect it. So take that and cut it exactly in half, so that this and this are exactly the same. So triangle, draw a triangle, take one of the angles and bisect it. Triangle by angle bisector theorem. Math people are not that creative in their names. So what that's saying is that if you take this one, CD, divided by DB, let's just say that's 3, then CA is going to have the same proportion over if you divide it by BA. And so 9 divided by 3 is 3, so 12 divided by 3 is 4. And they're just saying these ratios match if you have a triangle with an angle that's bisected. So triangle angle bisector theorem. So we'll do one example. Here's our triangle. And the angle that can be bisected can really be any of them, but in this case it's the one at the top. And so they told us these two are equal. So that means that 9 over 15 is equal to x over 25. So left to right on the bottom, and then left to right on kind of the sides of the triangle, or the top of the triangle. So that equals x over 25, and then cross multiply and solve. So 15x equals 9 times 25, which I think is 225. Let's see. Yep, 225. And then divide both sides by 15. And x is, I think that's 15. Yep. And no units there. And we get 15. So those are just 3 different kind of ratio applications of similar triangles. So to review, we had triangle proportionality theorem, which was this. We had 2 transversal proportionality, which was very similar, just so the top of the triangle cut off. It was this. And we have triangle angle bisector theorem, which has a triangle with an angle that's bisected, and this was the ratio. That is all. I just want to let you know, heads up, this is your homework. There's some proofs on there, or it says verify, so you can either write a proof or explain why. You just need to have some kind of explanation for those. I did proofs for my answer key, but you can write it out if you'd rather. And then your quiz is not going to be until Friday, so I will be here for that. See you guys soon. Thanks. Bye.